All right, let's dive into the hidden world of your computer. We're talking about operating system internals. We're going to uncover the city manager running the show inside your machine and explore a huge debate that shapes every device you own. Should it be built for pure, raw speed or for unshakable security? Let's get into it.
So, to get us started, I want you to think about this question for a second. How is your computer like a busy city? I mean, really think about it. You've got traffic, you've got different departments, security concerns. There are a million things happening all at once. If nobody was in charge, it would just be complete and utter chaos, right?
Well, that's exactly what your operating system does. It's the city manager that prevents that total chaos. It's directing traffic, handing out resources, and just making sure everything runs smoothly. And the master plan for how this city manager does its job, that's what we call OS internals.
So what exactly are OS internals? Simply put, it's the design blueprint for how the OS controls your computer. And at the very heart of it all is the kernel. You can think of the kernel as the essential bridge that lets your software, like your apps, actually talk to and control your physical hardware.
Okay, so now let's take a quick tour of the main departments our city manager, the OS, has to run. These are the absolute core services that keep your computer up and running.
There are 5 big ones, and they handle everything from running programs to managing your memory. We'll kick things off with process management. A process is basically just any program that's running. Your web browser, a game, literally anything. The OS has to play scheduler, deciding which process gets to use the CPU and for exactly how long.
Next up is memory management. You know, your computer's RAM is a limited resource. The OS is the one deciding which program gets how much memory, and it makes sure they don't step on each other's toes. So, for example, if your computer has 8 gigs of RAM and the OS itself needs 2 gigs just to operate, that only leaves 6 gigs for all your applications. The OS has to manage that space perfectly.
The other departments are just as vital. You've got file management, which is basically your digital filing cabinet, keeping all your data organized. Then there's device management, which acts like a translator, using things called drivers to talk to your printer, your keyboard, and your mouse. And finally, you have security and protection. It's the bouncer at the door, keeping your digital life safe and preventing anyone from getting in who shouldn't.
But here's where it gets really interesting. Not all these OS city managers govern the same way. See, deep down in the heart of the OS, there are 2 totally different, competing philosophies for how the kernel should be built: the monolithic approach and the microkernel approach.
So first up, we have the monolithic kernel. The idea here is that all the core services, we're talking file management, memory, all the drivers, they're all bundled together into one single massive block of code. Everything runs in what's called kernel mode, which is a super privileged space with total control over the hardware. Think Linux and Unix, they're the classic examples of this all-in-one design.
Now, the huge advantage of this is speed. I mean, it's incredibly fast because everything's in one place, so all the components can talk to each other directly. But, and this is a big but, there's a major risk. A single bug in one tiny part, say a faulty graphics driver, can bring down the entire system. It's a real all-or-nothing kind of design.
So what's the alternative? Well, that's the microkernel. The whole philosophy here is to keep the kernel as small and simple as possible, only handling the absolute bare essentials. Everything else, your drivers, your file systems, they run as separate processes in user space, which has way more limited access to the hardware. Good examples are Mach and Minix. The benefits here are huge: security and stability. Because all the services are isolated, a crash in your printer driver isn't going to affect the rest of the operating system at all. It's like having firewalls between departments instead of one big open plan office. But there's always a trade-off, right? And here it's performance. All these separate parts have to send messages back and forth through the kernel, which adds a bit of overhead and slows things down. This table really lays out that fundamental trade-off perfectly. Monolithic kernels are big and they're fast, but they're less secure. Microkernels, on the other hand, are small and secure, but you pay for it with a performance penalty. It's a classic engineering problem, really. Do you want speed or do you want stability?
Let's actually put a number on that to make it real. A direct call inside a monolithic kernel might take, say, 2 microseconds. Pretty fast. But in a microkernel, that same call needs an extra 5 microseconds just for all that message passing overhead, which brings the total up to 7 microseconds. That's the performance hit, right there in action.
Okay, So how does a program like your web browser actually ask the OS to do something, like save a file? It can't just talk to the hardware directly. It needs to go through a formal request channel, and that's where system calls come into the picture.
A system call is basically the official front door for a program to request a privileged service from the kernel. You know, the best way to think about it is like a restaurant. You are the program. The system call is your waiter, and the waiter takes your order to the kitchen, the kernel, to actually get the job done for you.
And there are system calls for just about everything you can imagine. There are calls for process control, like fork, which creates a whole new process. There are calls for file management, like open, to access a file. They handle requests for devices, they can fetch information like the current time, and they manage communication between different running programs.
Whew, okay, that was a lot to cover. So let's just boil it all down to a final cheat sheet, the most important things you need to remember from this deep dive.
So remember this. 1. OS internals describe the inner workings of an operating system. 2. Its key jobs are managing processes, memory, files, and devices. 3. There's a core trade-off in design. Monolithic kernels are big and fast. Microkernels are small, modular, and secure. And finally, 4. System calls are the essential doorway that programs use to ask the kernel for help.
And that leaves us with one final, huge question to think about. As our devices get more powerful and security becomes more important than ever, which one of these philosophies is going to win out? Are we going to prioritize the raw, blistering speed of monolithic designs or the rock-solid security and stability of microkernels? The answer to that question is going to define the future of computing.